Dividing monomials. Monomials can be divided using the exponent rules as well. So here we have an example. We're going to divide two monomials. You've probably noticed as you go on through the years that you see fewer and fewer division signs and more fractions. And that's because understanding division as fractions just comes with a lot more clarity, and especially in simplifying or dividing these different expressions, it's always better to have things as fractions. So the first thing I'm going to do in every division problem, if I see that division symbol, is just rewrite it as a fraction. And now all of a sudden you see that it's really just looking like simplifying expressions with fractions using our exponent rules that we did earlier. There's nothing special about monomials. And now we can apply our simplifying fractions skills that we've built up over the years. And so we'll start by simplifying negative 72 over negative 6. Well, each of those, first of all, the negatives are going to cancel. And then 72 and 6 can each be divided by 6. And then we're going to look at our letters in the monomials, or the variables I should say, and the a on the bottom is going to cancel out with one of the a's on top, and the 3 b's on the top are going to cancel out with 3 of the b's on the bottom, and 5 minus 3 is 2. And now we just go to our simplification, and 72 divided by 6 is 9, and we have a to the 6 left on top and nothing else, and on the bottom the 6's cancel out, leaving us with a 1, and we have just b squared left on the bottom. And so there is our division of monomials. In the second example, it's actually just a little easier because we already have it as a fraction, and we can just get right to our simplifying strategy. So we're going to divide, here's our monomials, right? Here's the first one on the top, second one on the bottom. So those are the two monomials that are being divided by each other. But you notice what it really just comes down to is that it's the same type of problem as simplifying expressions. It's the same strategy and same skill set that we use. So 30 and 48, what do they have in common? To me, the highest thing they probably have in power is the 6. So we'll start there. If there's more to be simplified later, we can do that. We're going to divide each by 6. Then getting to the letters, m to the 5 on top cancels with 5 of the m's on the bottom, and 11 of the n's on top cancel with 11 of the ones on the bottom, leaving just 3 n's left on the bottom in the denominator. So 30 divided by 6 leaves us with 5, and there's no variables left on the numerator. And in the bottom, 48 divided by 6 is 8, and then I have m to the 5 left and n to the 3 left. And there's nothing left in common between 5 and 8, and the variables are as simple as they get. So there's my divided monomials.